Lecture 3, Properties of Carbohydrates. To provide students with a comprehensive understanding of carbohydrates, including their structure, classification, physicochemical properties, and their significance in nutrition and food processing. Structure and classification of carbohydrates. Carbohydrates are organic compounds composed of carbon, hydrogen, and oxygen, typically following the general formula, C_N_H_2O_N. They are classified into three main categories based on their structure. Monosaccharides. The simplest form of carbohydrates consisting of single sugar units. They usually contain 3 to 7 carbon atoms such as trioses, tetroses, pentoses, and hexoses. Common examples include glucose, a 6-carbon sugar essential for energy, whose structure can be a hexagon in its cyclic form or a straight chain. Another example is fructose, a 6-carbon sugar found in fruits, with a pentagon structure in its cyclic form. Key characteristics of monosaccharides are their sweet taste and solubility in water. They serve as building blocks for more complex carbohydrates. Disaccharides are carbohydrates composed of 2 monosaccharide units linked by a glycosidic bond. Common examples include sucrose, which is table sugar and is composed of glucose and fructose. Then there's lactose, known as milk sugar, which is made up of glucose and galactose. Another example is maltose, which consists of 2 glucose units. Now, disaccharides are also sweet and soluble in water, but their sweetness varies. For instance, sucrose is sweeter than lactose. They can be hydrolyzed into their monosaccharide components through enzymatic or acid hydrolysis. Polysaccharides are large molecules consisting of long chains of monosaccharide units. Some common examples include starch, which is a storage form of energy in plants, and is composed of amylose, which is linear, and amylopectin, which is branched. Glycogen is another example. It is the storage form of glucose in animals and is highly branched. Then there's cellulose, which is a structural component of plant cell walls and is composed of beta-glucose units. It's not digestible by humans. Polysaccharides are generally not sweet and insoluble in water. Their structure influences their digestibility and functional properties in food. Understanding the physicochemical properties of carbohydrates is essential for their application in food technology. A. Solubility. Sugars are generally soluble in water, which makes them quite useful for sweetening and preservation, like sugar in syrups. Starches, on the other hand, are insoluble in cold water but can form a gel when heated and dissolved, a process known as gelatinization. Sweetness. Sweetness varies among different sugars. For example, fructose is sweeter than sucrose, which is sweeter than glucose. This property is critical in formulating food products, as it affects taste and consumer preference. Crystallization. Sugars can crystallize, which is important in candy making and food texture. For example, sugar syrup can form crystals, giving products like rock candy their characteristic structure. Maillard reaction. Reducing sugars like glucose and fructose participate in the Maillard reaction when heated with amino acids, leading to browning and flavor development in baked goods. Gelatinization of starch. Upon heating, starch granules absorb water and swell, forming a viscous gel. This property is crucial in cooking processes like thickening sauces and in the baking industry. Carbohydrates are the primary source of energy for the body. They are easily metabolized to provide glucose, which fuels cellular processes. Non-digestible polysaccharides like cellulose contribute to digestive health and can help regulate blood sugar levels. The brain relies on glucose for optimal functioning. Sugars are widely used as sweeteners in a variety of products, enhancing flavor and palatability. Sugars inhibit microbial growth by reducing water activity in food products, helping in preservation. Starch is used to improve the texture and mouthfeel of products, such as sauces and soups. In this lecture, we explored the fascinating world of carbohydrates, starting with their structures and classifications as monosaccharides, disaccharides, and polysaccharides. We delved into the physicochemical properties of sugars and starches, understanding how these characteristics influence their behavior in food. Carbohydrates play a vital role in nutrition as a primary energy source and are essential in food processing for flavor enhancement, preservation, and textural improvement. Understanding the properties and functions of carbohydrates not only enriches your knowledge of food science, but also prepares you for practical applications in food technology. As we move forward, remember that carbohydrates are not just energy providers. They are the foundation of many delicious and essential foods we enjoy every day.